So in this video, I'm going to be introducing a new strategy to find derivatives called logarithmic differentiation. And this is a strategy that I might use when I have a pretty complicated function with like lots of powers or something that I would use both the product rule and the quotient rule. But I wanted to start with a small example just so we can see the process. So the first step for using logarithmic differentiation is taking the natural log of both sides. So here's my example. I'm finding dy dx of y equals the quantity 2x minus 1 squared. So I'm going to start by taking the natural log of y, and then on this side I have the natural log of the quantity 2x minus 1 squared. And so the reason why I like using logarithmic differentiation is that now that my function is within a logarithm, I can use logarithmic properties to expand this and then create easier derivatives for myself. So over here we still have the natural log of y. And then using the power property of logarithms, I can pull out this 2 and then have the natural log of 2x minus 1. So at this point, after taking the natural log of both sides, this is when we introduce finding the derivative. So I'm going to take the derivative with respect to x on both sides. And let's make sure I have some equivalencies right here. So I have the natural log of y on this side. And then over here, I'm taking the derivative with respect to x, of 2 times the natural log of 2x minus 1. So in order for me to take the derivative on the left side, I'm going to have to use implicit differentiation. So I'm going to rewrite the derivative with respect to x as the derivative with respect to y of natural log of y times the derivative of y with respect to x. And then before I use the chain rule here, I'll go ahead and pull out the 2 since it's a constant. And I have the derivative with respect to x of the natural log of 2x minus 1. So in order for me to take the derivative of the natural log of 2x minus 1, I'm going to use the chain rule. So I'm going to say let u equal 2x minus 1. So going back to the equivalent expression, the derivative with respect to y of the natural log of y is 1 over y. And then we still have this derivative of y with respect to x. And now on the right side, I have my 2, but instead of the derivative with respect to x, I'm going to use the chain rule, and I'm going to have the derivative with respect to u of the natural log of u times the derivative of u with respect to x of 2x minus 1. So this left side will keep the same for now. We have 1 over y times dy dx. And now I have my 2. The derivative with respect to u of the natural log of u is 1 over u. And the derivative of u with respect to x of 2x minus 1 is 2. So altogether, if I want to simplify this, I have, I'll use this color. 1 over y times dy dx is equal to 4 over u. But because I let u equal 2x minus 1, I have this as 2x minus 1. So the final step here is to solve for dy dx. So I can see that on my left side I'm dividing by y. I want to multiply by y on both sides, and I will then have dy dx is equal to y times 4 over 2x minus 1. And then lastly, y is our function 2x minus 1 squared, so I can simplify this expression by substitute in 2x minus 1 squared for y. I can see that I can cancel out one of these. This will turn into a 1. And then overall I have the derivative of y with respect to x of 2x minus 1 squared is equal to 4 times 2x minus 1. So again, this was just an example to talk about the process of finding a logarithm using a derivative using logarithmic differentiation. If I wanted to check my work, I could use the chain rule, and we can see that by doing this process, we'll get the same answer. So this is a valid strategy. So if I have y equal to 2x minus 1 squared, and I want to find dy dx, let's switch to a different color. I'll say let u equal 2x minus 1. Then instead of dy dx, I'll have the derivative of y with respect to u of u squared, and then times the derivative of u with respect to x of 2x minus 1. So taking this derivative, I get 2u times 2, because the derivative of u with respect to x is 2x minus 1. So altogether I get 4u, which is 2x minus 1. So obviously in this example, it might be faster to use the chain rule to find the derivative of this function, but with more complex functions, using the process of logarithmic differentiation can save us a lot of time.